The PoV Word project. This circuit consists of a dual 14-segment display connected to two shift registers. The shift registers are tied together, allowing for there to be 16 total output pins. These outputs are connected to the anode inputs on the display. Two individual digits share anode pins for each segment, but each digit has its own common cathode pin. The first digit's common cathode pin is connected to the collector pin of an NPN transistor and positive through a 1K ohm resistor. The second digit is connected to the emitter pin of a PNP and positive through a resistor as well. The emitter and collector pins for the NPN and PNP respectively are connected to ground. The base pins of the transistors are connected to each other and pin 14 on the Arduino. The two shift registers, latch, clock, and output enable pins are connected to Arduino pins 10, 13, and 5 respectively. The shift register's master reset pins are tied permanently to high, and the breadboard receives power and ground from the 5-volt and ground pins of the microcontroller. When a user enters two English letters, they will be echoed on the display. Once the characters are processed, the letter's segment data is called and shifted out to the registers. They then present highs or lows on their output pins, illuminating the correct segments and displaying a letter on the display. It is impossible for both digits to display different information at one time. In this project, PoV is used to create that effect. The base pins of the transistors are either given a high or low signal, pulling the common cathode pins of the digits to ground or not, illuminating one digit of the display at a time. For this project, two files of code are required. The first writes all the segment maps to EEPROM, which library is included here. In the array at the top, the least and most significant bytes of the segment maps for each letter are defined. Written in binary, a 1 represents a segment on and a 0 off. 2 bytes of data are required to store the maps for each letter, as there are 14 segments. In the setup section, the maps are written to letters corresponding uppercase ASCII values EEPROM address, starting with A, 65, in a for loop. The second byte for each letter is written to the ASCII values address plus 26, meaning A's second byte of data is stored in address 91. The loop runs until every letter has 2 bytes associated with it, ending with 116, Z's most significant byte. In the second file, the EEPROM library is included, the pins are given names, and the variables that will contain the user input are also created, as well as the brightness value. The serial monitor is initialized and the pins are assigned to be outputs in the setup section. The output enable pin is written with the brightness value. The code then waits until input is available, at which point the first letter is read and assigned to letter 1. In case it isn't a letter, it is constrained to be 1. A short delay is next, followed by the second character being read and assigned. The letters are then converted to their uppercase equivalents, only if they are lowercase, by checking if their ASCII value is that of a lowercase letter and subtracting 32. The difference between upper and lowercase letter in the ASCII table. Finally, the segment maps are accessed from EEPROM for the letters and shifted out, with the most significant portion going in first. This is all done in a for loop which runs forever. The switch pin is set to high and low, timed with the shifting of the different data to turn the digits on and off with their correct letter showing, making for the PoV effect.